Yeah, hi, it's future me again. I realized that between cuts I had changed the clear color or the background color of the window. And in order for you to replicate this, just navigate to the draw method of the T-Rex Runner game class. And then here in the clear method of the graphics device, just pass the color white instead of cornflower blue. All right, back to the video. Okay, so let's think about what we can do next. And actually, no, let's start up the game here. Okay, so yeah, we can render our T-Rex now, and obviously this is not the correct start position. Oh, and obviously the window is way too large, right? We want to basically emulate the exact game size of the actual game. So let me just let me check in the actual game what the size is. There. Whoops. There we go. It's 600 by 150. So let's actually apply that to our game window. So go back here, go into the T-Rex Runner game class, and first of all, let's define those values as a constant. And they can actually be public because it might be handy to know from the outside of the class what the intended window size is. And since it cannot be changed anyway, it doesn't break encapsulation. So 600 and 150. And now we need to actually set the size of the game window, excuse me. And we can do that in the initialize method, which is basically what is called first after the game is constructed. We actually have to go via the graphics device manager, and there's a reference to that in this instance of the game class, and the field's name is graphics, and we can use that to set the preferred back buffer height and width. So we will use this property, whoops, we'll use those properties to set the new size of the window. Width, and then we need to call the apply changes method so that it actually takes effect. So I think this should be it. Let's take a look. Yeah, there we go. So it's exactly the same size as the original game. Obviously, we need to render our T-Rex a little bit lower on the screen. So the coordinates go from 0, 0 up here to whatever is down here. So the coordinates start at the upper left corner, and then yeah, increase. If I increase the X value, it goes in this direction, and the Y value, if I increase it, it goes into that direction. So let's see and open up the original game again. And there it is. And start it up and run against the cactus. If there ever spawns one, there we go. And let's see here. Obviously the T-Rex is yeah, doesn't spawn in the upper left corner. So let's see what its actual position should be. Roughly, let's make a screenshot of this, paste it into some image processing application, and then $15. So the difference between the edge of the screen and the T-Rex character is 15 pixels. So obviously its positions should be 16 pixels from the bottom. So that would be 600 minus 16. There we go. Let's just say something like this. And the X position should be possibly 16 as well. No, actually, I think it's just 1. I think there's just 1 pixel between the edge of the game window and the actual T-Rex sprite. So let's say it's 1. And then when we instantiate our T-Rex here, we can then simply say T-Rex position as T-Rex start pos X, T-Rex start pos Y. There. Now, let's see. Nope. I must have miscalculated. Oh, right. Because the origin of the sprite is its upper left corner. So we need to also factor in the size of the sprite to determine the actual start position. So let's see. Oh, right. We actually pass the position here to the constructor, so we can do that. Like this. And we actually have to say here minus, what was the size again of the sprite? I think we have a constant for that, right, in our T-Rex? Yeah. But I think it's private. Yes, they're private. Now let's just make it really simple and just go ahead and go into the T-Rex class and make, whoops, that was not intended, and make these constant values public. That's all right. Wait. Yeah, so yeah, that should be all right. It doesn't break encapsulation since they're constants anyway. We cannot change them. So the start position minus the height of the sprite, like this, and then we should be good. Yeah, looks good. So perfect. And now what I want to do, if we look into the actual game and let's refresh this. Let's actually close this in debug mode here. And if we don't press anything, I think it sometimes blinks. It just blinked. It actually just blinked. So yeah, it appears to be blinking when it's in this idle state. This is probably what's going on here. You can render this image, this sprite, to the screen in the background, and then render the actual T-Rex over it, so that the T-Rex is in the foreground and this image is in the background, and our T-Rex has an animation, a blinking animation. But since our T-Rex is rendered in front of this image, it will cover it completely. Not completely, but the actual shape of the T-Rex, and then you will be able to see the blinking animation. So I think this is what we can do. Let's do that. So let's go ahead and go into our game. It's actually still running. Let's stop it. And now let's create a new field of type sprite and call it, I don't know, idle T-Rex background sprite. And then initialize this field in our load content method. Give it a texture, and the texture is obviously the same here, the sprite sheet texture. The X and Y, I think we can go with the same dimensions. I think that's all right. Yeah, it would probably be all right. So we just need to know the coordinates. This is 40 pixels. And then after that, the target sprite starts, right? Yeah. It should be 40. So let's go with that. Let's go into the game and let's see here. Should we maybe actually make this part of the T-Rex class instead of the game? Yeah, I think we should do that. Let's remove this here. Remove the sprite here and go back into the T-Rex class, and then here instead create a new field of type sprite and call it idle background sprite. And then in the constructor we say idle background sprite is an equals new sprite, and then pass the sprite sheet here. And then let's see, let's add a new constant here, make it private first. T-Rex idle background sprite pos x equals 40, and then the y position is 0. There we go. And here pass those values to the constructor of the sprite. There we go. And the width and height are the same, so we can just pass those same values. T-Rex default sprite width and height. And there we go. And now when we draw the T-Rex, we will check if it is in idle state, because we have a state property here. And if that state is idle, we will first, before we draw the T-Rex itself, we will first draw the idle background sprite. At the same position actually as the T-Rex. So I think this is a little cleaner than doing it in the game class, because it shouldn't really be a responsibility of the game, but the actual T-Rex entity, I think. And let's see. we can actually, you don't have to use this keyword, but whatever, it's the same. Yeah, so actually in the constructor, let's make sure that it starts out in the idle state. So here in the constructor, set the state to idle. Actually, since idle, I think, is the first value in the enumeration, yes it is, it would be idle by default, but let's just explicitly set it to idle, so it's also more transparent to us as a developer. Yeah, let's go back into the game class. And I think, let me just start this up. It should now actually render the correct idle sprite. Yes, it does. Perfect. Yeah, now it looks exactly like the original game. And yeah, now what I actually wanted to do before I discovered this, before I was looking into when exactly the blinking animation plays, is yeah, what I wanted to do is actually implement those animations. We know that there are animations, obviously this blinking animation, but there's also other animations. For example, the running animation, the running while ducking animation, and also there's the animation for this little pterodactyl kind of character, what we were referring to as the flying dino. It also has a flying animation, so we need to be able to describe and implement those animations, and for that we will need a new class. So let's go back into our model here in our diagram, and let's see how we can implement this. Let's create a new class and call it sprite animation. And what does an animation consist of? Well, really it's just a series of sprites, right? So basically our animation needs a series of sprites. So and these sprites will be triggered at a different time. So let's visualize this real quick. Let's see if I can do this off the cuff. So basically we have some sort of timeline going on. So we have, let's say we have like a virtual timeline going on, and we start at 0 seconds, beautiful, and we go to, I don't know, 2 seconds. And then at 0 seconds we have 1 frame. So this is the first frame. First, for example. And after that, after the certain amount of time, so this would be, I don't know, roughly half a second. And then there's the second frame. Second. And I don't know, then here you have the third frame, and so on and so forth. So basically we have to yeah, create some sort of timeline with frames that contain or reference different sprite. You will get what I mean as soon as we get into the code. Let's go into the diagram here. So obviously we need sprites in our sprite animation, but also they have to have a timestamp or time frame when they are going to be displayed or triggered. So let's in turn create a new class and call it, I don't know, sprite animation frame. Zoom in a little so you can see this better. And one sprite animation frame consists of the sprite. Let's add a new property of type sprite. And the timestamp when this frame should be applied or should be rendered, should be triggered. So another property of type, let's say float. It should be the number of seconds in the timeline when this sprite should be drawn. So let's say timestamp. And I'm not sure if it makes sense to be able to change the timestamp, because that would enable us to basically mess with the timeline. So maybe we should make this immutable. Yeah, I guess. So the sprite can be changed, that's fine, but the timestamp should not be changeable. So yeah, so let's say this is an aggregation, because a sprite animation has a sprite, but a sprite can still exist without an animation. So if the animation frame is destroyed, doesn't necessarily mean that the sprite is destroyed as well. So let's see. And our sprite animation in turn consists of a number of sprite animation frames. So again, here, and this time, use a composition, because if the sprite animation is destroyed, all of its frames are obviously destroyed either. So in our sprite animation class now we will add a field. And this field needs to be some sort of collection that can store all of the frames. So let's say private list of sprite animation frame and call it frames. And maybe make this a little bigger. Sorry. Yeah, should be fine. And now let's see. The sprite animation consists of a list of sprites. That's fine. We need to be able to add new. A list of sprite animation frames. And we need to be able to add frames to the animation, obviously. So let's create a method here. And it will be named add frame. And it will simply take the sprite that should be drawn in that frame and the timestamp. And then let's say have a method. I mean, let's only include the methods that we really need. For now, we don't really need a method for removing frames, because we're not going to create animations and then remove frames from them. So let's not implement this for now, and possibly not at all. But we will have to make it possible for the animation to play. So it needs to be updated, obviously. So add a method update, and for calculating the new position in the timeline, we will need a reference to the game time. So yeah, let's see what else. Tidy this up a little. Yeah, it doesn't matter. So yeah, what else? It needs to be able to be updated. We need to be able to tell the animation to start playing and to stop playing. So let's add a method and call it play, and add a method that is called stop. We could also implement a method for pausing the animation, but I don't think we need that. I don't think we will ever have a use case for that. the animation either plays from the beginning or it doesn't play. So I don't think we need to be able to pause it. So, but maybe we should be able to tell whether or not the sprite animation is currently playing. So let's add a property for that. New property, and put it on top here. And it will be a Boolean property. Oh, sorry. And it will be named isPlaying. And it returns true, obviously, if the animation is playing. And you cannot set it from the outside, so it will have a private setter. And it will be set to true whenever the play method is called, and will be set to false whenever the stop method is called. Okay, then maybe we need to be able to reference the individual frames. We can either do that with a method like getFrame that takes an index, or we could implement an indexer. In C#, it's possible for you to actually implement your own indexer. And what I mean by that is an index operator, like you use when you reference an element in an array or list, for example, using the bracket, this bracket syntax. We could do that. But let's make it. Yeah, I don't know. We could do either, or we can do both. Yeah, let's actually go with the indexer. Do we have the possibility here to add an indexer? I don't think so. Well, let's just model it here as a method. It doesn't really matter. So let's see, sprite animation frame, and name it getFrame. And as an argument, we will take an integer named index, and this method will return the frame at the given index, or throw an exception if the index is out of range. And we can, like I said, also implement an indexer that does the exact same thing, but I will show you that. I will get into that when we actually implement this in a bit. Let's see what else. We need to be able to update it, play it, stop it, get the individual frames, and I think that's it. We don't need to be able to remove frames, so that's fine. Yeah, I think we're good. Oh, actually, we need to somehow store the current. If we take another look here, the current. So this is the timeline, right? So it goes from. Whoops. So it goes from 0 to 2 seconds. This is an arrow. This is supposed to be an arrow. So we need to be able to store the progress of the playback progress of the timeline. So after the first update, it's maybe here. Then after updating it again, it may be here, and so on and so forth. We need to be able to store that. So yeah. So I hope this timeline thing is clear. So maybe I can. So we have a timeline that goes from 0 seconds to 2 seconds in this example, and it proceeds. As it proceeds, we need to store the current time value to store the progress of the animation, and then according to the current value, the current process of the animation, we can tell which animation, which sprite, which frame should be rendered to the screen. And this is what we want to model here. And actually I just saw that this should be named frames, of course. But I think our diagram is complete so far. Oh no, sorry. Obviously, let's add this new property of type float. may as well be double for extra precision, but float should do. And call it, I don't know, playback progress, maybe. You shouldn't be able to set it from outside, but it needs to be set from within the class. So it's going to have a private setter. Yeah, doesn't really matter. So, okay, let's see. But I think that's it. Yeah, let's actually code that now. So we need two new classes, sprite animation and sprite animation frame. So let's take care of that. So yeah, obviously we created a graphics namespace here and a graphics folder accordingly. That's actually quite fitting, so let's put it in there. Let's go to add class and say sprite animation frame first. Let's make it public, even though we don't really need to. And we need to have two properties. First of all, the sprite that should be rendered. We could make sure that this is not null, which actually would make sense, because since sprite is a reference type, someone could assign null here, which doesn't really make sense. Why would there not be a sprite within this animation frame? We don't really need to take that extra step, but we could do that. Let me just show you what I mean. So you can make sure that this is not null by, for example, providing a backing field here actually, and not use an auto property. Since this is an auto property, right? This actually what the compiler will do, it will actually automatically include a field, a backing field for this sprite, and then in the getter return that field, the value of that field, and in the setter set the field to the value that was passed to the setter. So we will do that now manually. Whoops. To be able to include some additional logic. Like this, and then here, let's actually format that differently here. In the getter, simply return the sprite. So this is a so hold on, let me just quickly finish this. This would be here, it automatically says that this is redundant now, and we could use an auto property because the auto property would do the exact same thing. And this here is an expression body. It's just a short form of writing this. It's the exact same thing. So we can do either. Let's actually put it like this, and then say here sprite equals value. So, but an auto property would do the exact same thing. So we just save ourselves the hassle of implementing this boilerplate code by using an auto property. But since we want to make sure that this sprite is not null, we can here in the setter say if value equals null, we would throw an argument null exception, and here pass the name of the argument, and then an exception message like the sprite cannot be null, something like this. So this way we could make sure that no one assigns null to this sprite property, because it doesn't make sense. But you don't really need that extra layer of security, basically. But yeah, I just wanted to show you how you could achieve this. So yeah, let's go ahead and also include the timestamp property like this. And then obviously we don't need a setter. Then obviously we need to have a constructor. And I just typed ctor and double tapped, and it will automatically stub out a the code for a constructor, for a default constructor. And now let's add the actual arguments and set them accordingly. Oops. Like this. So if here again, I'm using the property instead of the field for the assignment, because now if someone was to pass null, the setter of this property would be called, and here it checks if the value equals null, and then throws an exception if so. And yeah, then an exception would be raised if someone was to pass null to this constructor. And here you can see that there's no setter, and I'm still able to set the timestamp still, which at first glance may be weird, but what's actually happening is here is that the compiler, this is also an auto property, but it's a read-only auto property, and what the compiler will do is it will add a read-only field like this, and in the getter return the value of this field. Yeah, but you can abbreviate this by just simply using this auto property, this read-only auto property, and then you can only assign a value to this once, either here directly here or in the constructor. So yeah, after that, this value cannot be changed anymore. And now in this context, it makes sense, because then you would be able to change the timestamp afterwards, and it kind of would mess with the timeline of the animation, and we don't want that. So yeah, this should be fine. Let's create another class and name it sprite animation. Also make it public, even though it doesn't really matter. And then create a new field of type list. And as the type parameter, pass the sprite animation frame and call this field frames. And in this case, we can actually directly initialize the field here instead of in a constructor or something. That should be fine. And then we don't need a specific constructor. The default constructor will do, I think. And let's see. Yeah, let's take a look in our diagram. So we implemented this field now. We also need this isPlaying property and the playback progress property. So let's include them as well. Bool is playing. And we don't want to be able to set this value from outside of the class. So let's make this private. Excuse me. And then also, whoops, implement the property playback progress. And also make the setter private. And again, these are auto properties. The compiler will automatically, behind the scenes, add appropriate fields for those properties. But we can save ourselves the time to write the boilerplate code. Okay, so let's take another look at the diagram. We need a method named addFrame. So let's actually implement that. Public void add frame, and here take the sprite that should be included in the frame and the timestamp when the frame should be applied. And what we will do in this method is we will actually create a new instance of sprite animation frame, and let's just call it frame. Call the constructor that we created, pass the sprite here and the timestamp. And now we need to add this frame to our timeline, which is basically this frames list. So frames add frame. So now we added this frame to our list of frames. That's it. Yeah. It's really that simple. So now let's see, we need an update method as well, which takes the game time as an argument. And the game time class is in a different namespace from the MonoGame framework, so that's why Visual Studio doesn't recognize it at first. So let's use IntelliSense to get rid of this error, and it will add a using directive here, including the namespace, so that's fine. Let's actually implement this later. Let's take another look. We need a play and stop method and get frame. And yeah, let's do that now. First of all, play. And for now, all the play method will do is set isPlaying to true. And then stop, which will obviously set isPlaying to false. For now, I'm not sure if this will actually, if there will be more logic here later. Let's see. And then we need a way to reference or to access the individual frames from outside. So let's implement this other method from our diagram, sprite animation frame, and it's called getFrame, and it takes an integer named index in this case, and it should return the frame in the timeline with the given index starting at 0. So let's take another look here. So this would be indexed, so this would be the first frame, but its index is 0, like in any collection, like in an array. Then the second one would have the index 1, and so on and so forth. And in order to be able to, for example, access this specific frame, one would just call the getFrame method and pass 1 as the parameter, and the return value would be this frame. So let's do that. It's actually quite simple. First of all, we need to check if the index is within the correct range. So if someone was to, for example, pass -1, doesn't make sense. Or if they pass 47, but we actually only have 2 frames, that doesn't make sense either. So if index less than 0 or index greater than or equal to frames count, throw new argument out of range exception and pass the name of the pass the name of the argument, the parameter that raised, that is the cause of the exception here. So we can use the name of operator for that, which will actually return the name of the given identifier as a string, we could also just make it say index as a string literal. But then if we change this here, it would still say index. If we instead use the name of operator and pass the argument here, and we were now to rename this, obviously now it would also return I, so it's a little more clean to do it like this, but it's also not that big of a deal. So here let's pass a message that should be shown then, and it's something like a frame with index does not exist in this animation. Something like this. So if someone passes -1, this condition will be true and an exception will be thrown, and it will specify the name of the parameter that caused the exception, which is index, and then it will say, as an exception message, it will say a frame with index -1 does not exist in this animation. So then the developer who called this method knows exactly what went wrong. So, but if this condition is not met, then obviously everything is fine and we can return the correct frame. And let's say return frames index. And this is the index operator, the indexer, which I referred to earlier. And what we can do is actually also implement our own indexer, index operator, in this class to make it even easier to access the individual frames. And we can do that by like this. Hold on. Public sprite animation frame this. Like this. And what this enables us to do is do something like, if you were to, let's say we're somewhere else in the code, right? And we created a sprite animation like this, and then add a couple of frames, and then we want to access a specific frame. We can go, for example. So this would then return the frame at index 1. And this works, well, what does it say? Yeah. So this would call this indexer here, this index operator. It would, what it actually does in the getter, it calls the getFrame method, which does the exact same thing as simply saying anim.getFrame1. So this is just for convenience. I'm not sure if we're going to need it. I just wanted to show you that this is possible.